Hello everyone, I'm Wafula Yenem and today presenting to you my project the housing system. So one thing, what's this project all about? So we know that nowadays there is a vast variety of housing alternatives for people. So it's hard for people to find places to reside in that meet their needs and are within the convenience of their pockets, or they can afford them, or they yeah. This is also made harder by the exploitative brokers who sometimes take advantage of people because of the because of and they end up providing, like, let's say, houses that don't match up to the standards of the people and don't fit in the prices that they really expect. But with AI, this can be solved by training a system which can be able to which is able to excuse me. This system will be able to choose or to select for people the locations and houses they need when they input the let's say the prices they can afford, and also the number of housing facilities they need. Yeah. For the dataset I'll be using is a California housing prices dataset from the cargo, obtained from the cargo dataset repository. Here it's adapted from the median house prices for the California districts, derived from the 1990 census. It's made up of comma-separated values containing the categories as listed below: the longitude, latitude for the location of the buildings or the houses and accommodation. The housing median age, meaning this is the age, let's call it the average, the median age of the residents in the block. Total number of rooms, total number of bedrooms, population, households, median income, median house value, and proximity to the ocean. So these are some of the features that were used to classify the housing features used to determine the needs for the user. So some of the factors that were considered is that this dataset had a vast variety of instances which are actually 20,640 in number, and these offer the learning algorithm a wider learning rate or range from which it will learn how to be able to identify the needs of a certain client or user. And then the format of the data also. The data is in the format of comma-separated values, which are easier to manipulate, access, and use. Yeah. Some of the features of this AI model used include the longitude and latitude, which are used as measures to locate the houses. The more negative the latitude, the further west the building is, and the higher the longitude value, the further north it will be located, of course. And the total number of rooms also is another feature which the system will be learning from. And these are the total number of rooms on a block, or let's call it a building, since these are kind of apartments. And then population, which are the total number of people living on a given block. The median income for households within a block of houses, which are also measured in tens of thousands of dollars. All of these values will be of the data type float, meaning they will be float values. Yeah. Here's a simple description about the Bayesian theorem. This is what we should know about the Bayesian theorem is that it's mathematical theorem used to determine conditional probability. This theorem states that the conditional probability that an event based on the occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. Yes, and that's the formula for finding the Bayesian probability. And these are the terms used whereby A and B are the events, and B into A over OB is the probability of A given B, which is true. So, and the others, as you can see there in the video. Then it should know that in machine learning, this Bayesian theory provides a useful method which identifies the relationships between the datasets and the probabilities. This means that the probability of a given hypothesis being true can be stated as finding the probability of observing the data given the hypothesis multiplied by the probability of the hypothesis being true regardless of the data, and divided by the probability of observing the data regardless of the hypothesis. It should be noted also that naive Bayes classifiers are a simplified version of the Bayesian theory, or Bayes theorems as some people refer to it. Yeah. And also here we can talk about the naive Bayes, since we've been talking about the Bayesian theorem and it's a classifier. It's a classifier of the naive Bayes is a classifier that deploys the Bayesian theory. The naive Bayes algorithms are classification techniques based on the Bayes theorem, as we had stated it earlier on, with a strong assumption that all the predictors are independent of each other. The fundamental assumption is that each feature makes an independent and equal contribution to the outcome. Yeah. So in Bayesian classification, the main interest is to find the posterior probabilities. The posterior probabilities, that is to say the probability of a label given some observed features. The probability of L given features, which is expressed as probability of L given the features. With the help of Bayes theory, we can express this in quantitative form as follows, as the formula below describes it all. Yeah. The naive Bayes models are classified into three, which are the Gaussian naive Bayes, the multinomial naive Bayes, and the multinomial and Bernoulli naive Bayes. For the Gaussian naive Bayes, these are the simplest naive Bayes classifiers, and they work on the assumption that the data from each label is got from a simple Gaussian distribution. For the multinomial naive Bayes models, here the features are assumed to be drawn from simple multinomial distributions, and they are most appropriate for features that represent discrete counts. So, lastly, the Bernoulli naive Bayes. In this model, features are assumed to be binary in terms of ones and zeros. Some of the applications of the Bernoulli naive Bayes can be text classification. Yeah. When we talk about the Bayesian networks are widely used for probabilistic graphical models that can be used to build models from data or expert opinions. They consist of two parts, which are the structure and parameter. The structure is directed acyclic graphs, which can be abbreviated as the GAG, which expresses conditional independencies and dependencies among random variables associated with nodes. Whereas parameters consist of conditional probability distributions associated with each node. They are commonly referred to as Bayes nets, belief networks, and sometimes causal networks. Bayesian networks are compact, flexible, interpretable representation of a joint probability distribution, and useful tool in knowledge discovery, as the DAGs allow representing causal relations between variables. The capability of the Bayesian networks is expressed in four major analytics disciplines, which include the descriptive analytics. Under this, we have the automated insight, large patterns, anomalous patterns, multivariate, and we also have the diagnostic analytics. These value of information include the value of information, reasoning, troubleshooting, and tracing anomalies. Then there is also the predictive analytics, supervised and unsupervised, anomaly detection, time series, and latent variables are some of the let's say fields that can be where the predictive analytics can be deployed. Then there is prescriptive analytics, which include the decision automation, cost-based decision making, decision support, decision making, and uncertainty. Yeah. Then here we see, let's have a look at the differences between the Bayesian theorem and the naive Bayes. The naive Bayes assumes conditional independence, whereas the Bayesian theorem does not. The Bayesian, and also our thing is, the Bayesian theorem is a mathematical theorem, whereas the naive Bayes is a classifier which depends on the Bayesian theorem. So the naive Bayes is more dependent on the Bayesian theorem, whereas the Bayesian theorem is an independent mathematical theorem. That's what I can say about that. Then for the differences between the naive Bayes and the Bayesian networks. Bayesian networks are probabilistic graphical models that use Bayesian inference for probability computation, while naive Bayes are probabilistic classifiers based on the application of Bayesian theorem. Naive Bayes assumes that all the features are conditionally independent of each other, whereas all the dependencies in the Bayesian networks have to be modeled. Yeah. So what I can say about the differences between the naive Bayes and the Bayesian networks, or belief networks. These are some of the references I was able to get my content from. Yeah. Thank you for listening in, and I ask you to subscribe to my channel and drop a comment, like and share. Thank you.